Hi, everybody. Welcome to our today's climate lecture from the Vienna Biocampus. I'm Jeroen from Climate at Max Perutz Labs, and we're a grassroots organization trying to make life science research more sustainable. And today we are very pleased to have Inge Jonckheere from the Food and Agriculture Organization from Rome, from the UN. And she will talk about satellites observations and how we can use it to tackle climate change. Inge started her studies and did her PhD at the KU Leuven in Belgium, and then she moved on to the European Science Foundation in Strasbourg, already working on satellite observations. And then in 2009, she moved to Rome to the UN office from the Food and Agriculture Organization to continue this work. This is also what she will talk about today. And next to working for this UN organization, she's also an IPCC author working on greenhouse emissions. And then finally, before I hand over, she also participated in one of the ESA programs to get trained as an astronaut, but she will not talk about this today. But if you have questions, also feel free to ask her in the chat. As always, we'll have the talk first, but feel free to already drop questions in the chat. And at the end of the talk, you can either raise your hands to ask questions, or I will moderate the discussion at the end. This is the last seminar which is planned, but if you have ideas or if you want to hear speakers, we're always looking for interested talks or interesting topics, and we're happy to organize the seminar. So feel happy to reach out to our email address at climategroup@maxperutzlab.ac.at. So with this, I hand over to Inge. Can you share your slides? Yes, super.
Yes. Can you see it well?
Yes, thank you.
Okay, so thank you very much. Thank you very much for the invitation. Thanks for all listening in. I hope I won't bother you with the next 45 minutes. Thanks for the introduction, as said. So I won't talk about the ESA training, space training, but who's interested, of course, you can contact me. So as said, I will talk about remote sensing. So my background is remote sensing and Earth observation and the role of it in tackling climate change. So as you mentioned, so I'm an IPCC author. I'm from Work Group 3, which means mitigation, but I will talk about way forward for climate mitigation and also adaptation. So please follow me in this part. So just for everybody to know, I think this crowd is very aware where we are. It's a climate crisis. And as you know, IPCC last year came up with some publications. It's a cycle. And last year was a publication of the mitigation and the adaptation report. And it was clear that it said that we're not on track to limit the warming to 1.5 degrees. I very often get the question, why these 1.5 degrees? Well, in the climate modeling, we have seen that beyond the 1.5 degrees, there will be very significant changes in the way ecosystems will respond to the global warming. And so this is why this has become a target also in the UN negotiations and in the COP negotiations between parties. So as you can see, we're not on track. It was the highest emission in 2019. And so we really have to do something about it. So all this is, of course, in the framework of environmental change, as just said. So the climate crisis is here and now. So IPCC has clearly said that. Now, why is it so important that IPCC reports? I think most of the people in this talk are working or linked to climate, and so we're all aware what's going on. But IPCC has now also proven, based on more than 20,000 peer-reviewed papers, that the real science has shown that it's human-induced. So, of course, there's still climate deniers, but based on the science, I think there's really no way forward to put this against. So the monitoring and the forecasting of land due to this climate crisis has become more crucial than ever. We're very often talking on a global scale. So we have a lots of variety of data and data sources. So we call it the global data sets. And then FAO, more specifically my team, we work on a national scale. So sometimes we use global data nationally or national data for different reporting frameworks. As you might know, all the countries have to do a lot of international reporting to show where they stand and also what they do in their fighting climate change. So FAO, so the Food and Agriculture Organization, for people who don't know, is a specialized agency of the UN. Headquarters is in Rome, so this is also why I'm based in Rome. And we work together with Silva Carbon, which is the US capacity building part, in collaboration with the European Space Agency, academia, and also other partners. So our main role was to really develop tools and techniques, I could say, to really assist these countries in the measurement, reporting, and the verification. Through GFOI is mentioned here. So GFOI stands for the Global Forest Observation Initiatives. So as you might imagine, there's a lot of players in a lot of developing countries. And in order to have one voice and a harmonized approach, this is why it was grouped into a Global Forest Observation Initiative. So if we look, for example, on the REDD+, so REDD+ stands for the Reduction of Emissions by Deforestation and Degradation, which is a major initiative following the COP negotiations on climate. And it's in the framework of the UNFCCC. So it means that it's in the framework of the UN on the climate change. And here, without going into specific detail of countries, you can see that from 2014, when for the first, and as you might know, Brazil was the first to really submit a reference level, we came a long way. And you can see that there's a lot of countries which have followed the example of Brazil based on the fact that now they also have a monitoring system. I will go into detail later about that. So just for you to show that all these countries have done the reporting to the UNFCCC, and eventually, of course, the main focus was there to see that they could really reduce emissions and they could also access climate finance, because all of these monitoring systems can only be viable and sustainable if there's a follow-up also with finance. So how does that work? So we call it activity data. So this is that methods AD. So it stands for activity data. So a reference level needs to have the data, so the area, linked to also the emission factors. And if we take these two, then we get the greenhouse gas emissions. So just for you to show, so far, so I have the figures for the 2022, there have been 56 reference levels submitted, meaning that the developing countries have submitted to the UNFCCC Sector 10 Bond a report in which they say what was the reference level and showing which effort they will do to reduce emissions from all these different activities. So you can see there's quite some different ways how they work with it. Also here you can see different results. So some use simple pixel count. So they use satellite data and they count the pixels which have changed. Some use statistics and some use sample-based approaches. So just to show, without also going to specific detail, please, if you have more questions, I can elaborate on this. So to show that maps are used, satellite data are used, and then some used wall-to-wall or some sample-based approaches. So the area, of course, needs the emission factor in order to really see how much greenhouse gas has been emitted. And so most have a national forest inventory, or they have inventory data suitable. So here you can already see that whatever happens, we need ground data and we link it to satellite data. Of course, also, if you would have a fully fledged national forest inventory in a country, of course, you could also do it without the satellite data. But the good part of the satellite data is that it goes back to 1972, in which Landsat started to really record data all over the world. Most of these countries don't have national forest inventory history, so they don't have a data series. And so the satellite data allows for using it backwards and also to go along. So this is the reason also why the role of remote sensing is so important. So if we then look the complicated landscape, and as I said before, we really need carbon finance. The countries need carbon finance opportunities in order to keep this whole system, national forest monitoring systems, viable. And you can see there's 3 ways here. So we have the result-based payments. So that's when countries really show that they have reduced emissions, they can receive payment for that. Then we do have the compliance markets and the voluntary carbon markets. So I won't go to the detail of this part because I think we can have a full talk about this one. But just for you to show here, there's different donors, there are different schemes. So the Green Climate Fund, we have the Foreign Carbon Partnership of the World Bank, and then we have different standards to which you have the country or the one who's submitting the request have to really adapt. So you have CORSIA, which is done for the aviation reduction, Vera and R3s. So the monitoring is a big part because of course you can once in a time get a carbon stock, but the whole part is the monitoring. We want to see the changes. And these ones we need to link to the policy needs because in most of these developing countries, there's now a setup of a monitoring lab, but it also has to go into the policy and also into the reporting. Some of the data really has to go into the political context of the country before it can have access, for example, to climate finance. So one thing we did in my team was like to check if the data really brought better decisions. So I've been working in the UN RED program. So UN RED is the UN answer, you could say, to the RED mechanism, which was negotiated in the COP decisions. And we really checked if better data really brought to better decisions. So sometimes it's a very political part to report some data, for example, uncertainty. But of course, we came a way, if you see, 10 years ago, we were also from a technological point of view. So we saw that we need a better integration of measurable field, airborne and spaceborne parameters, and then linked to practical land and forest monitoring solutions. So this is something which more and more countries are focusing on and really also to try to apply all these tools to the different reporting frameworks. So from our part, so the capacity building, implementing agencies, I think we all agreed that there's more support needed in the domains of agriculture, linked to food security, raw materials, the inland and coastal waters, and forestry. In all of this, very often it goes about carbon. Carbon is the main focus, but also these other domains linked should be taken into account. And then finally, mitigation efforts versus adaptation. So for people who are aware of the different negotiations, so mitigation was really the key until the Glasgow COP, in which we thought that we had to put everything and all the funding on the mitigation, so reducing emissions. And it's still a crucial part of everything we do in the climate crisis. But I think, unfortunately, here and there, we already lost the battle, and we really also have to focus on adaptation. So new monitoring should be explored there. So agriculture practices, all management, which really can also, for example, through soils, to really try to have the best solution for the most vulnerable countries, which really have an impact from the climate change crisis. So how do we do this and what can we offer? So I hope there's some very practical people also in this seminar, because I will go through some of the concrete applications we have developed in FAO. Our main politic is all open source, open data, open source. And so we do work very closely with academia. So a lot of these applications have been developed together with universities, as long as it's possible for the applicant or for the academia to have an open source and to share the code. And so we're very willing to also involve this in our package. So if you're a PhD or a postdoc and you do have some algorithms which you think can be useful, don't hesitate also to contact me. So the first part, we call it the Open Forest Initiative. So here's also the website. So as said before, it's open source, free and open source, and we call it methods for data collection, analysis, and reporting. As mentioned, so I'm in FAO, I'm in the forestry department. So our main focus is forestry and beyond, and then also, of course, land use, land cover. And so we came up with a suite of models really for developing countries to help them to collect the data, analyze, and also report it. So you can see here, we do have an online platform. We have some tools, collect mobile and calc to as you could see it as for national forest inventory, in which data is collected, but then also calculated in order to give biomass and emission factors. And then on the row below, you can see Collect Earth Online, EarthMap, and SEPAL. And these are the geospatial tools which were developed in FAO for use in countries. So Collect Earth is a tool also as a survey for data management. It's online because there's always a mobile version, so you can use it simply on a mobile phone. And then EarthMap and SEPAL, which are processing platforms in the cloud, which allow for data generation for activity data. But I will go into detail all of them. So maybe back to the key principles. As I said, free and open source, extremely important for us. All codes are available in GitHub. And then collaboration, as said before. So Google is also a partner, and then a lot of academic institutions. Boston University, for example, is a big one, who gave quite some algorithms for change detection. And then all these tools have been country tested. We talk about more than 130 countries which have been testing these tools. And then linked with that, always there was capacity building. So training sessions, online, hands-on, but then also remote, and especially since COVID, more and more MOOC, so massive open online courses. And so for now, we speak 44 countries have really integrated this in their monitoring system. So I think we are beyond the proof of concept step. For people who are interested, please don't hesitate to try it yourself. So then SEPAL, that's one I know very well because I'm one of the founders. So we started with this Earth observation and cloud computing platform, and it came from the fact that by doing capacity building in developing countries, very often it was very some internet connection, and then also the way to transfer data. So I'm talking about 15 years of capacity building experience. So of course now we're in a different time frame. So the cloud-based platform, it's much more, let's say, well spread. But again, SEPAL is free and open. Anyone can simply register. So you have to just fill in your email, and then with an internet connection, you can have access. So below you can see a wide range of partners and also collaborators. So to show that's a really collective approach. It's not FAO standalone. We really use the cutting edge science of academia to really move ahead with this. So then I won't go into detail, but that's a little video for SEPAL. Given the resolution, I won't do it here, but if you go to the website of SEPAL, you can also see it there. It will show you how you can go through the different steps for the observation, data access, and so see it as a tool for GIS, so Geographic Information System, and satellite data, also for dummies. So for people who are not really experts in the field, but who can accept and also understand the processes behind. So this is the website again. It has many capabilities. It's also very dynamic. So as said, we collaborate a lot with academia, with other partners, and then all the tools and modules which have been created are always based on a need of a user need, so a concrete need of mostly of a country, in which then we respond to. So you can also see mobile and tablet compatibility, the storage and access to data. I'm talking about, of course, all the different archives of the open data, Landsat, Sentinel. We have then also, thanks to a NICFI collaboration with the Norwegian donors, we do have the full part of planet data, which is high resolution satellite data, which can be used also in non-profit applications. So then you can see, so that's to analyze and predefined processing for all kinds of topics, mainly data generation to really generate data for these reports for the different international reporting frames. So then there's no in what we can do or what we can offer, but just for you to show an example. As I said, most of these countries generate data SEPAL for the activity data, for then the reporting, for example, to the UNFCCC. And then, as you know, every thing you do with data, there's always need for accuracy assessment and uncertainty. And one of the very difficult things, especially for people who are not very familiar with analysis, also from geospatial data, there was a need for the stratified random sampling for accuracy assessment to really show how map or how maps be used also for the statistics, which then part of this reporting. And so this is a module who helps for the accuracy assessment. So then there's a link to Collect Earth and Collect Earth Online. I'll talk about it in a minute. But so Collect Earth is a tool. It's the same geospatial part, open source, can be used to produce training data. Everybody who works with satellite data, you need to train data. As said, you need field data. And Earth is an easy tool in which people who have no formal background in remote sensing easily can use it to produce training data. So as you can see, we call it a visual interpretation tool for land use cover classification and also change detection with high and very high resolution data. So high and very high resolution because in case you don't have field data, in order to create training data, of course, it has to be from a better resolution than the image you have originally. So this is why very often it's with high or very high satellite data. So for example, here you can see an example. So this is a data collection tool which is integrated. So we work, as said before, with Google. So we also have tools in Google Earth. You will see all the GitHub. And so there you also have free access to the very high resolution imagery. Multi-temporary, so that's thanks to Google Earth. We have Bing Maps and then high resolution. As said, we also have the archive of planets, thanks to an agreement with NICFI. So that's also very powerful for the tropical zones. So then also Collect Earth Online, meaning that it's in a platform that you don't have to download the whole archive to your computer. So you can all do it in the cloud. And so that's used globally. So maybe just to show you one example. So for people who don't work with satellite data, so you have active satellite data, which is called radar data, and then optical data is the data as we know it through normal sensors. And very often the radar data has different outcomes than the optical data. And by combining them, it might be sometimes useful to have more information. So for example, something which can be done on this platform of SEPAL, you can see here, so ALOS, that's radar data from Japan. Landsat data is the archive of the US, which is openly available. And if you combine both, so even people who have no clue about what's going on here, you can see that you have more information by bringing these two sources together. So this is, for example, something which can be done with SEPAL. So I talked already about the planet data. So it's pan-tropical and high resolution. Of course, amazing opportunities because it's if you can see more detail in data, you can do more and have more information about it if you use it in a useful and sensible way. So this is what I wanted to show here. So this is also from a concrete project. It's called Africa. West Africa, they really wanted to validate some of the maps which had been made in order to have better forest management and also to decide where they would have the national forest inventory plots. So as I said before, in order to come up with change map or to show change also for reporting purposes, you have to show that there's a difference. So you need to have statistically sound data, and this can be validation data. This here to show you that based on maps, there has been a validation tool created in SEPAL. So people who have no background in remote sensing very easily can use it to validate maps. So then, so only making maps on national forest inventory or to have reference data. So there's a lot of applications, if you can see in all these countries. And this is an example, what you, for example, can do with forest disturbance. So I said we don't invent our own tools. We always come up with solutions for existing problems. And so a lot of the countries, and as you can imagine, a lot of developing countries have quite some disturbances and they really want to see what's going on before they can see it on the ground, or to react before it's too late or because the damage can be too big. So basically, we create for them a graphical user interface, so always very user-friendly, with a whole capacity development program in which then the knowledge is always transferred. You can see then from the right-hand side, this is a GUI, so it's based really on what the country wanted, so to interpret the time series data. Because if we talk monitoring, it's always over, it's not time only. And then, for example, here, they were allowed to make maps of disturbance based on the data. Maybe the high resolution data we can help to really show the detail of the disturbance. So then linked also, we have a FERM platform. So we call it for the restoration. So as you might also, 2022 started as a UN decade for restoration. Restoration very important also because very often the mitigation has not done the job. So this is why also restoration now has major attention. It can also be part of one of the adaptation measures. And so in the restoration, we have different streams, but one is the terrestrial one, which I know best, but there's also a whole part on inland waters and mangroves. And so thanks to this high resolution data, the user would have access to existing data, also under the different international national framework reportings, and then you can see how they can combine. So for example, in this case, it could to have different indices which are linked to the modules in SEPAL and different areas of interest which can use user automatically adapt themselves. So, so different frameworks, similar indicators, same data. It's a bit the question brought up before. So better data, better decision. We all know that politics are very important and have a major weight. But of course, if the policymakers can be informed with very good data, indicators, very measurable, understandable, it really might help, and it really might also enhance the policy to implementation part. So here you can see some of the different frameworks we will work. So we have the CBD, United Nations FCCC. Something also important is a convention to combat desertification. And then linked to that, FAO stat. So FAO has an official database. For people who don't know it, feel free to explore. So it's really state of the art with data for the different countries, all the FAO members, which are almost all members of the UN, and then linked to the SDGs. So I'm sure you all have heard about the Sustainable Development Goals. The countries now have to report also on these. And so one of the things which always pops up is that now we have all these different frameworks that indicate but how can they really keep on reporting in a useful way. So what we try to do from our art is come up with tangible which can be used for the different reporting frameworks. So then how see this all? So what we can do, of course, I'm going to all the details how you can use this remote sensing. So for anybody who's interested, please feel free to let me know or after this. But I think it's important so that for the agriculture, the forest, and the alternate land use, we can not only provide large-scale reductions, but there's absorption and CO2. So talk about remote sensing. Most of the work we do is with optical data, and I think that's also all around the world because in a way there were more sensors, more open data, and a bit more easy, let's say a less steep learning curve. So this is why also now more and more the link is made with the two. But then we look at the above ground biomass. So of course we also need to look on the different levels. So as seen here, so we can trees can absorb and store CO2. So this is why we need to make the link to biomass and not only the cover. In all this, also from the IPCC, we've seen that agroforestry, reforestation, avoiding deforestation can really enhance productivity, livelihoods by renewable energy. And so also there, we can use remote sensing, for example, to make better suitability maps where we can plant different trees or we can have different forest management practices. Something, and here I speak with the head of the IPCC. So we've seen that there were really positive impacts using certain international and also climate policies on reducing emissions. For example, deforestation really has shown that we really could reduce emissions in different countries. And it's a bit too early to say whether these zero deforestation pledges from the public and private sectors are really effective, but at least it's really a good step ahead. So really indicating and showing that everything we do, and this is also why I was saying with the data and the policy, it really has to be interlinked. So you can have extremely good data, you can have extremely good maps, but if it's not linked to the policy, then it's very little which can be done. And so it seems very straightforward, but unfortunately, that's still a major gap which needs to be bridged. And so therein, the next point is very good link to this. So achieving all these ambitious climate goals really relies on international cooperation. So from the talk here today, you can see that all this comes from the FAO. So it's an implementing agency working with developing countries. We're not alone. There's a lot of NGOs, a lot of other implementing agencies. As I mentioned, Silva Carbon. We also have GIZ, for example, from Germany, which is a big one. I'm sure there's a lot of other ones. And so these transnational partnerships are so crucial in really to play a role as a technology, knowledge, and experience shared. So sometimes people ask me, why do you think it's so important? Because if we talk to a lot of the developing countries, they're extremely poor. Of course, we're way ahead in the Western country where we are technology sometimes, and very often cutting edge solutions are not the solution there. But we can also see that by helping them in their international developments, sometimes we can really jump some of the, let's say, development steps which we had been making ourselves. I always use the example of, for example, a telephone line. Like I think I live in Italy, and I think some of these African countries have a very good system on transferring, for example, money, everything with the telephone, with the mobile phone, while they never had maybe landlines. So they really skipped a step and they really went a heap ahead. So I think that's also a very important role for the international cooperation. So then if we really look specifically to the Earth observation data, so everything with satellite data, we need long data records and then data over remote places. So as I said before, in some of these developing countries, the satellite data is crucial because they don't have a history of national forest inventory. And so when you don't have that, the satellite data, which was recorded anyway from the 70s, can really be a help to show how it was and to give a baseline. So we need it for validation, as I've shown in an example here, also for climate models, but for all kinds of models. For the monitoring and the early warning, so I said, sometimes you can see something before you can see it on the ground. So it can help to really mobilize also implementing groups or let's say also foresters to really show where something is going wrong. So imaging spectroscopy, so also radar can be very crucial there. We need Earth observation also simply to understand the processes. I think the IPCC report, as it was published last year, would not have been where it stands now if we didn't have Earth observation data. So really to show big models on the global, national, and local scale. And then from my side, of course, I know there's also a whole business around it, but I think for what we do and how we see it, we really need free and open Earth observation data. I think Landsat from the US has shown that by the uptake of the Landsat data after it had become an open archive has been so exponential, and can also do, of course, it can also be used for making money, but one of the parts is really in this climate part, it's really impressive. And so no data without policy. So what is then for global climate change? Our wish list, or maybe my wish list from policy side. So really, there's need for more support in mapping changes. The whole thing we're talking about. As I said before, we don't, of course, it's important to know an absolute amount of carbon stock, but I think most also reporting frameworks and also the climate finance, it's all in the changes. So that's why we really need reporting mapping that and help in sustainable forest management and also agricultural practices. So as I said before, there's a major effort which has been going to mitigation so far. Me, myself also, I've been working mitigation until recently. And so now we really will focus and also shift gears to adaptation, because as you can see from all the natural hazards which are ongoing, we really need to help the most vulnerable countries to really invest for these climate impacts. So then something mentioned also before, so there's a lot of optical satellite data, which owns to the biomass, also the soil, important. A lot of these scientific papers show also the impacts and all the very high part as well. So I think this is a very big research. And then for assessment and also assessments on biodiversity, ecosystem stability, and environmental action. Before, focus has been very often on carbon, at the point of negotiation safeguarding, because it's not only about the carbon. And then more and more we look into also sustainability issues to go on that. So also there, lake coastal systems for quality is also something which should measure attention. And then I told already about new products and services. We do have Copernicus services from Earth observation in Europe, which really a lot of services in different domains. So then the way forward, so we can do something. And I think this is also might be for the scientific community. So I think before developing any tool, any nice connection, it's really needed to take into account user requirements. Sometimes I really see the gap between cutting edge science, which has developed in a lab, and then looking for use. While in this field, very often the user requirement should be really at the start. I say this just simply because from what, my own experience of these fields in capacity building, I can see for what we do, we really need to include the users from the start, especially talking about developing countries. And then another part which some people who are not so much in capacity building world think of is the data ownership. So I've seen so many amazing global national data sets, also products which were made in the most advanced labs, which unfortunately very often lie in some drawer without being used because simply end users don't feel ownership of it. So I think there, especially for people working with remote sensing data and Earth observation data, I think by including end users, even if it's in the validation phase, I think it can really help to increase that the data really seen as owned for the end users and not as something that's just brought in, especially in developing countries. And then for people who are wondering which important policy frameworks I was talking about. So we have the Sustainable Development Goals. So here we have a few of them, so 12 and 15, more specifically, because they also link to land cover. And then, well, we have all these EU policies, agricultural policies. We have the Convention for the combating desertification and land degradation, and then also the UN Convention on Biodiversity. So with this, I think, well, and I put again up the IPCC hat, so the evidence is clear, we really have to act. And I think I finish with thank you for your attention. So this is the website of the FAO, and I've also put my email for questions after, or happy to answer any questions you might have now. Thank you very much.
All right, thank you very much, Inge, for the nice talk. There was a few times the sound was a little bit off, so I hope everybody understood most of it. If people have questions, please drop them in the chat, or feel also free to raise your hand. The group is not so big, so we can also take questions. I just have a start question maybe. So most of the images and sensing is done for I guess Africa and South America, I guess, right, or Asia too. Is there a similar tool for like developed countries, or are they supposed to do it themselves, or how does it work?
Well, it's a very good question. So as said, and if you remember one of my first slides, so all of this is based on the National Forest Monitoring System, which was in place in Brazil. So Brazil is always seen as a developing and a developed country. So they started with these systems. Now, FAO then took over and then developed them for the countries who asked for them, who don't have it. Now, the thing is, and which I didn't mention, you have a few options. So you can do everything with field data, and then some of our Nordic neighbors, meaning Sweden or Norway, they're very, very good in national forest inventory, and they have a whole history how they do it. So they hardly use any remote sensing data. If we look then to middle of Europe, it's a mixture. Belgium, France, they use the different ones. And then if we look then to Canada, for example, or New Zealand, so very advanced in everything that has to do with monitoring, they have models, which can also be done. And in order to have a model, then you need, of course, much more data, because you need much more indicators, which you have to fill in order for your model to be representative. So the only thing I can say is that SEPAL as such, so the cloud processing platform, is used a lot also by developed countries, scientists, but more on project scale or scientific project scale, I would say, not on national scales. But of course, it's out there. And the thing is that the main donor is Norway, but they do it still with the National Forest Inventory. So not so much with the remote sensing data. Yeah. But that's more historical.
Okay, so, and then there was a question from Rupert in the chat, was talking about open source data, and he was wondering if OpenStreetMaps, which I just looked up, which has the trees on it, is also considered a database for monitoring.
Yes, so thanks, Rupert, that's a very good question. So yes, all the open source data is available in the SEPAL. So OpenStreetMap is also part of it. Bing Maps is part of it. We have the Google archive with all the Landsat, Copernicus, all the available data. FAO has ALOS data from Japan, so it's also on there. And then, well, the people most interested in the planet data archive, which I showed. So that's, I think, less than 1 meter pan-tropical. So it's between the 30th north and 30th south grades, in which you could have daily overviews and then also monthly composites. But yeah, everything that's open source is considered database for the monitoring.
Yeah, and then there's...
Sorry to interrupt, but maybe just a short follow-up question on that one. Because for the OpenStreetMap, there's always this kind of struggle to get to a high-resolution satellite imagery, and I kind of got that sense from your presentation as well, that there is this kind of data bottleneck, especially regarding satellite imagery. So how does the FAO work with that exactly?
Yeah, well, so as said, we have the fortune to have the database of the planets, and we have it since, I think, since 2 years now. And so we do have the daily composites for all the regions where we work. So basically, we can link it in that part to the OpenStreetMap, and then also to the other existing high resolution data, which might be, for example, bought in these countries. Yeah, but so yeah, we have the luxury for now for the planet data, and from what we can see from the Norway, they're very keen on at least 2030 we'll have. So we will have a good data series there of planet data.
Okay.
Thanks. Very good question.
Thanks, Robert.
Yeah, thank you.
There was a question from Anna Guy. How do you transfer the capacity to use these platforms and remote sensing skills to the general user with very little experience? I guess this is a...
Yeah, that's an extremely good question, Anna. So yeah, here I can say, so basically the idea when we came up with SEPAL is exactly also because how do we deal because remote sensing, even for people who just students from bioengineering, for example, who are not specialists in it, it might all looks very difficult. So this is why we start with having the platforms extremely user-friendly. user-friendly, meaning that everybody with basic knowledge of computer, of course, you have to be able to set a computer and work with it, can access. So it's with tabs, it's very well documented, it's with instruction videos. So in all that, it's very user-friendly. But then what we also do, and that's also something we realized, you also have to go hand in hand with capacity building. So we do trainings. Before COVID was mostly in country. So we do have in-country trainings in all of these countries, which I mentioned, but then also in most of these projects, there was also an international responsible who was living in the country and working with them. So in that sense, then it was even, of course, easier even to work with it. But the key is to make it very user-friendly and to have a lot of capacity building activities. And as mentioned, so now after COVID, we also saw that these MOOCs, so it stands for these massive open line courses, which also, if you're interested, I can send you the full archive. So FAO has an extremely well-developed platform of e-learning in which you can, on your own page, go through all these trainings from all the different parts, which I mentioned here. In all the languages, because we also see that in a lot of these developing countries, it's a language which is an issue. So I can tell you that SEPAL has also been translated, for example, in Vietnamese. So in that sense, to really make sure that they can do it. And then another part, of course, we cannot train the whole world or everybody who wants to work with it, but we do have this trainer of trainers in which we do have capacity building events and in which people then go back to their country and train it to the people in the country. So this is a formula which has been working quite nicely. And I have to say that also after COVID and with these MOOCs, we've seen that there's way more participation of women, which for some reason it was very hard to get them on the live trainings, but then that they really managed, thanks to, I think, better time management in the family, to have access to the trainings. So I'm very pleased with that, that at least that gender balance gets a bit better with online events.
Super. There's a question from Alice. She asked, like, Vera was mentioned as one of the players in carbon finance. Mm-hmm. And there was this scandal where The Guardian, I guess, uncovered that some of the projects did not really work or had hugely inflated figures. Mm-hmm. So does it seem that relying on estimates and self-reporting rather than real verification? So the question is, how should we scrutinize these tools of carbon offsetting?
Yeah, just add to that. I think the issue is, of course, Inge, that they use forest protection, right? And so it all becomes very tentative and theoretical. And I know that this is in principle not considered good practice. I just wonder what your thoughts or views are on that.
Yeah. Well, of course, we were quite shaken with this publication, and for information, I was called by the journalist just before he published. Of course, I couldn't stop the publication. But I think, well, the good part of this publication, at least, is that people now talk about it. Now, the verification part is a very difficult one. I think it shows also that the verification should be even much more scrutinized. Of course, remote sensing can help there, but I'm afraid to say that also for some of the Vera project, also remote sensing was used. So I think what's needed there is really, well, Anna was asking, how do you give training to people who have no clue of remote sensing? I think also for Vera verification, I think these reviewers should also be trained in these tools, but it's a bit the same as UNFCCC reviewers. If when we have to do the reviews of the BURs, you also need to know what has been reported, because yeah, you can just take it for granted or you can recalculate. And I think there, what's going to be needed is that these standards get much more tight, not so much in the way they report, but in the verification of it, because I think that's what it shows, that the verification is the weakest link. All the rest, yeah, and the reviewer should then be also extremely scrutinized on everything they do with the figures. I think, well, part of it, because the unfortunate part, which I see in all these publications, is that I don't think it should comment really the fact that there's a project ongoing, because then you could also say, well, we don't do anything anymore. But I think because it has a lot of other benefits, also the safeguards. As said, it's not only about the carbon. The good thing is that, well, the main issue with these Vera was the carbon, but then I think the fact that these projects are ongoing has a lot of other benefits. But the verification should be much more scrutinized for sure. Yeah. Thanks.
Thank you.
Flavia in the chat says, thanks for the great presentation. Just today, there was a paper using AO data for national greenhouse gas inventories submitted, and the adaptation of biomass and carbon data is very low. So what is missing for countries to use more data from satellite imagery, such as biomass or carbon data, is her question.
Yeah. Thanks, Flavia. That's a great question. So I think it goes a bit back to one of the slides I brought in. So how can we use remote sensing data? So if I go back to 2011, before the Landsat archive was open, the data was there, you could use it. But then in 2011, when it was open, we saw that also a lot of countries did not use it. So countries, developing countries, needed to be shown their way around how they could use it and what would be the benefits. And I'm afraid that it's the same with the CCI, with the biomass and the carbon data, together with the fact that all these amazing data sets, especially the global ones, are made somewhere in the lab, and countries don't feel ownership. You might have heard of WRI, which is an organization in US, which has a platform called Global Forest Watch. It's an extremely nice platform visually, data which is globally made with a global algorithm. So you can see already and imagine that for all these ecosystems, the uncertainty over the different nations is very different. So for some countries, it's really amazing, I have to admit, but for some, it's really far from reality. So countries really need to feel that the data is owned. So the same with, if you have these biomass data, you have these new biomass who will think on a satellite. So basically it's global data, and then it needs to be, let's say, nationalized or adopted for national needs. And unless that's done, I think it's very hard for countries to see that as their data. So if it's a bit linked to the Jeroen's question on what of these developed countries. So why don't they use all these methods where we come up with? Because, for example, Sweden with their amazing national forest inventory, they know what they do. It costs heaps of money, but they have their forester going into the field, they collect the data, and so they have their baseline, and then they use this. So it has to be a country-owned process and also a part of their data. And if this is not something we will better make sure of, they're not going to use it. And this is exactly a discussion and dialogue which I very often have with space agencies, because I know also DLR from Germany is very, very high on helping countries, ESA as well, but as long as they don't respect the nations with their own process and the way they see to generate data, I think it's very hard to make them use the data because they don't see it as theirs. So I think that's the future, to really include them from the start, and or at least use them with the validation of data. Yeah, I hope this answers that question.
Yeah, if people still have questions, we still have a few minutes to ask questions. Oh, Alice has one.
I have one more question. I mean, this is slightly sort of going down a different path, but I'm currently looking at artificial intelligence a bit more, and sort of the benefits also to environmental protection, right? And so in all of what you're saying, and I'm a total sort of non-IT expert, and I'm a non-scientist also, as you know. I mean, so the systems you've described, I mean, they present a lot of opportunities, right? And including for verification, but including for data ownership, etc. But in terms of what they actually do, I mean, is it what aspect is actually, where does AI come in, basically, yeah? Or where is it just it's just big data? Where is it just digital sort of technology? Can you comment on that a bit? Sort of basically, I'm trying to see what does really AI do to help countries protect their ecosystems.
Yeah. Well, so AI, I don't even know exactly how they sometimes define it. So they call it artificial intelligence. But I think from what I can see, what we've been doing the last 15 years, it's linked to the deep learning. It's trying to really see what matters between the really amount of data we have now. So as you can already see, I think from this presentation, there's so much data out there, but really so much, going from the raw data, which now you haven't seen only products, but you can see raw data. You have all these different options, optical data, radar data, you have maps, you have statistics, so that it's becoming, especially for non-specialized data, specialized countries, extra information. So I think what I now main focus, and this is also why we're looking into this, is to help them and to see what's really important. Now, one of the tools for which we, for example, use AI very intensively is really to look for anomalies from normality. So as said before, we have data series. We have so much data, and especially in the satellite data, we have time series. And so time series allow you to make up a pattern, which you can see what's normal. And now we start to detect from the normal situation. So in that sense, AI can help a country to warn, so we call it early warning systems, to really prevent almost something that will happen, and then take it over from there, or to once a hazard has really like a flooding, for example, has come in, that what you can do to impact and to try to tackle it. So I think from what I can see from my part is that really our response from governments, actually, because by just knowing it, it's not enough. It really has to be linked to an implementation policy tool to really adapt and to act much quicker. Now, as said in one of my first slides as well, so I think what's still lacking, because for example, also Turkey, I don't want to go into the details, but if you look at some parts, some of the scientists really knew everything was going on. So why was there no action taken? So again, that link between action plan and policy is so crucial with everything. And I think AI helps, at least from the data side, to generate better data in order then to prevent or to tackle different parts and to see what's really important between all the data which is there, because I think I can say that we live in a time where there's too much data, because you could say all data is useful. No, I can send you the report, better data, better decision, and you'll show that in our time, I think that's not the case anymore. We should better use the right data, I think.
All right.
That's helpful.
Thanks a lot, Inge, for this insights.